Hello everyone. I'm excited to be here in our third Data at Scale event. It is amazing to be speaking to so many industry leaders. I'm Barak and I support Meta's Data Infra teams. That means I wake up every morning thinking about data and I finish my day thinking about data. And yet, with the crazy evolutions going on in the data space, not a single day looks the same, and I'm always learning new things. Today, we thought we will bring some of that excitement onto you, and especially focus on the AI data-driven infrastructure. We will do a quick recap of where we were in 2022, our last Data at Scale event, where we are now in 2024, and we'll follow with where we believe the next set of challenges lie. And if this tech discussion sounds a bit too tech, I'm excited to share that later in today's program, you will also get to hear from DJ Patil on how do these technologies touch all of us in real life. But first, let's talk about how we got here. In 2022, in this exact event, we put a lot of focus on the AI ML revolution. And our partner Amani, who was doing the keynote back then, talked about the massive change in this introduction. These days, it feels like that was an understatement. We're in the midst of navigating a generational shift. It is truly one of those inflection points in the history of computing. This might sound a bit hyperbolic, but believe me, this is a great time to be working in tech and in particular in the data space. To put things in context, I want to talk about some inflection points in the past and some of the patterns we've seen when we see new technologies emerge. There has been a series of maybe 5 or so major transformative milestones in the history of computing. And I mean major steps, among thousands in between. We have to start, obviously, with the transistor, the most elemental part of the logic circuits. This is the first transistor, from 1947. It replaces vacuum tubes and more cumbersome switches, relays, and amplifiers. We would now miniaturize and make a lot of technology, like TVs and radios, more reliable, cheaper, and obviously smaller. It laid the groundwork for novel applications like advanced logic and computing. The next major innovation, and this is admittedly skipping ahead a long time and a lot of innovation, which gets us to the next major computing leap, is the personal computer. The PC jumped us ahead from large mainframe computations to more advanced programming. PCs first made programming more efficient. We did not have to write in assembly or use punch cards. We could write DOS and eventually use graphical user interface and even the mouse. I don't know how many of you even remember there was a time before the mouse. And only then we could talk about what Bill Gates said, a computer on every desk and in every home. I still have fond memories of my first PC. It was an Apple IIe. That was my first step into an amazing journey in tech. I probably would not be standing here in this spot if not for that first PC experience. The next major pivot point was the internet itself. With things like Alta Vista and Yahoo, ICQ and MSN Messenger, and later on Google with search and YouTube, the internet made a whole host of things in our world more efficient and easier. We moved from mail to email, to online shopping and e-commerce, and above all, it made an infinite amount of information available at your fingertips. It created a new generation of businesses and services that simply could not have existed without the internet. Think about Amazon and Netflix. And then comes the cloud. How huge that was. Initially it was about, if you were too small to run your data center, maybe you tried this thing. I still remember hearing a CEO of a Fortune 500 company call this out as a minor fad in 2013. And then in 2017, there were reports that cloud workloads represent over 75% of the industry. As someone that was deep in startup arena during these years, I really experienced this firsthand. My first venture was pre-cloud, and we really sweat through many IT problems before we could actually get to solve our key problems. The second startup was after the introduction of the cloud, and was a dramatically different experience. The cloud almost eliminated these IT problems overnight. And these revolutions didn't just enable smarter, smaller startups. It enabled much bigger companies to go through major revolutions. Think about massive players like Netflix. One pattern that emerges across these inflection points is that each of them brought major change to the industry as well as to our lives in many ways. And it's also visible that we're seeing that the pace of acceleration growing, and the events are coming closer and closer in time. Obviously, the next milestone in this journey was the proliferation of AI and ML. And this meets us in Data at Scale 2022, where data in the lens of AI ML comprised the major part of the event. My colleague Aparna was on this stage back then and introduced the key points we see in the data infrastructure world as we take the impact of the AI revolution. I thought I'll take a few minutes to recap on what has happened since in each of these dimensions. In 2022, Aparna called out these 5 points, and since then we have seen major evolutions. We have seen more applications of AI being trained at a much larger scale. Across the industry, it is now common to see recommendation systems trained on thousands of GPUs, leveraging distributed training to allow better experiences to their users. In the world of ranking and recommendation, a key trend over the last 2 years has been longer user sequences. The tech now allows us to take into account many more past events, and as a result, provide a much better experience. But as we are building long user sequence of thousands and tens of thousands of user interactions, we need to deal with more features, models, and we need to evolve our infrastructure to handle those, and as well as the difference between analytics data and training data. We evaluated file format requirements and designed a new file format called Nimble that provides encoding flexibility and better controls for workloads optimization, optimizing for compression, read and write costs, and allows us to optimize our workloads. We have also introduced Velox into our data infra ecosystems. Simply put, Velox is a high-performance native data processing engine. One of its key features is the ability to process data in vectors rather than individual records. Velox, like Nimble, was developed by Meta to address the extreme data scale needs of growing AI applications and was introduced to open source community so that we can all keep pushing the industry forward together. And why take my word on this? What says demand has outgrown supply more than the Nvidia stock graph over the last 2 years? And it is not only software. We are seeing more companies working on their own hardware to help relieve supply shortage and allow better optimization and performance and scale. And on that front, Meta recently announced its first AI accelerator, the MTIA V1. I'm inspired by how far we've come in such a short time since Aparna's keynote in 2022, and proud of everyone's efforts to innovate on data demand, optimization, infra, freshness, and observability for broader AI efforts. And while we are still working hard to evolve our data infra to allow the AI revolution to happen, and in many ways we are still early in the journey, we now see that it pales in comparison to the challenges being introduced with the Gen AI revolution. As someone that works on these challenges every day, I thought it might be helpful to share my view of what drives success in the Gen AI space. And I will frame these under 4 buckets. First, obviously, is the model, where research is evolving at extreme speed. Since the launch of GPT-3 in November 2022, it has barely been a year and a half, and we have seen the tech evolve in ways that normally would have taken many years. GPT moving from 3 to 3.5 to 4, Llama 2 to Llama 3, Bard to Gemini, and these are just a few examples. Second comes compute. To build foundational models, companies need jobs running GPU clusters much larger than we have ever imagined, moving from thousands to tens of thousands of GPUs and even larger clusters has been key in this innovation race. To the point that Meta recently announced it will be running 600,000 GPUs by end of the year. The other 2 are straight in our backyard. The data space is key to making Gen AI models work in both the scale of data it feeds as well as the quality of the data. In many ways, data is the secret sauce of foundational models. As we progressed from Llama 1 to Llama 2 to Llama 3, a major part of the process was driven by adding more data of higher quality and higher diversity. This enabled higher performance models, and each generation of models added 10x investment in both the quantity and the quality of data. Let's go deeper into the challenges data for Gen AI needs to tackle. First is scale. To allow models to train on data at this massive scale, we need new ways of collecting and storing data. We need ways of handling different modality types. Processing massive amounts of text is very different than massive amounts of high-quality videos. And then there's a long list of questions that frame our journey, starting with what would seem basic. How do we catalog all the different data sets that build this massive corpus of training? How do we make sure every piece of data gets properly reviewed for privacy, security, and integrity policies? How do we balance this extreme scale of data with the desire to allow researchers to be super nimble and quick to experiment, as well as fail fast? How do we allow them to visualize data sets with trillions of tokens? How do we help hundreds of engineers collaborate in order to create a technological feat, such as releasing an industry-leading LLM? And then come the infra challenges. When we think of those, we can talk about fault tolerance. What do we do when a multi-month job fails? Obviously, checkpointing helps, but it also opens up a ton of other challenges. And what about co-location? Keeping data and compute, in this case GPUs, close to each other so we don't melt the network. And trust me, it is not a pretty sight when you get close to melting your network. And then you need to redesign things almost on the spot. So be proactive about it. Think of data placement considerations that take into account the data center capacity to ensure training efficiency, avoid GPU starvation, maintain GPU load balancing. And these questions lead to much more interesting discussions, all the way to how you design your data centers going forward. These are massive changes, but even with these, it's not going to be enough as we think about the future. And this is what really intrigues me. As we move to the next versions of Llama, and knowing that as you extend into more bizarre sources of data, you are likely to get less quality tokens. I wonder, is there even enough high-quality tokens on the web? At what point do we switch to new sources of training data, like synthetic data? When we think about data, we should also be thinking about the quality and diversity. And it's not just that LLMs are very prone to garbage in, garbage out, but we feel data quality is a real differentiator in this game. For one of the key differences, we think we got massive wins in Llama 2 and then in Llama 3 by introducing much smaller scale models of much higher quality data. And we could compete with larger models that did not put same emphasis on data quality. Examples of data quality dimensions we care about include picking data sources with high concentration of knowledge and removing gibberish from the content fed into the training data to maximize learning per token and minimize level of noise. We believe in removing duplication of data to avoid memorization and making training more efficient. And in general, giving high priority to higher quality and validated information sources has proven to be an efficient way for us to go about training. When we think about diversity, we think about building models for the whole world. This means supporting diversity of language, diversity of modalities, be it web documents, research papers, various kinds of media, and diversity of knowledge domains. All of these need to be reflected in the data being fed into the model. It's only with massive diversity we'll be able to solve a large range of problems, from retrieving facts to generating poems and videos, to doing product research and allowing to buy something, and solving hard math. And then comes responsibility and safety. We want data that is helpful, harmless, and honest, like factual. We first need to ask ourselves, how do we make sure the data sets we train on isn't biased or harmful? We need to make sure data is not doing harm, i.e. not toxic, safe for work, and avoid other integrity risks. And we need to make sure that the data is fair, not biased towards age groups, genders. As we are proactively developing technologies to address all of these risks, we also expect regulators to help the whole industry maintain a high bar on these dimensions. Training data for pre-training and fine-tuning heavily depends on scale, quality, and diversity. And due to these traits and others, it would take a lot of time to train models at this scale. So by the time the model is shipped, some of the data it was trained on is already outdated. We also know a model can't answer questions it was not trained on, and that there are specific use cases that depend heavily on the freshness of the data, such as news or results of a recent sports game. And there's even a more extreme use case when we want to deal with events in the future, such as getting the agent to find tickets to a hot show where tickets have not been released yet. The outcome is that models cannot rely solely on their training data in order to respond to events in real time. We need to get the model to understand how to go about acquiring the needed information, even if that information did not exist in training time. The industry is doing this through a combination of tools, as well as leveraging the inference time context window. On one hand, we see more and more tools that models can leverage and get to validate the information they need in order to respond. And on the other hand, there is an ever-growing context window into which we can bring relevant data so that the model can properly answer different use cases. In closing, we talked about where data infra plays in GenAI, and I want to recap the 3 top points. Multi-model datasets require unprecedented scale. And this we are seeing data scale that pushes our systems to extreme, challenging many of our past assumptions and bringing interesting problems into light. Then comes quality and diversity, which are key for creating leading models faster and at lower cost, allowing players to leap ahead in the innovation race. And we are seeing that data at training time has limitations. These can only be addressed by models that, at inference time, know how to go about getting the data they need. They do this through tools as well as utilizing more of the inference context window. And now, if we go back to the series of industry inflection points, the next technology that could pop up is artificial general intelligence, or AGI. To be frank, we don't know if and when AGI will happen. We could easily go into another AI winter before we see AGI coming, or we may never see it at all. But at the current pace of innovation, this could also be just around the corner. I will leave it to you to guess. And to conclude my time with you, I want a quick reminder of why we do at-scale events. These are meant to allow us all to come together as an industry and a community. And this is a core part of the Meta DNA. We see open source as key to progress. In this talk, we touched on Llama, Velox, and Nimble. All of these are now available to the open source community, with the hope that together we bring the industry a major step forward, which no single company could do on its own. Thank you, everyone.